with these next questions, we're going to do this in reverse. We're going to be given the picture of the graph and then try to figure out what needs to fit up here. But before I do that, let's look at a couple examples of things that I created to kind of help maybe better understand this. First, there's where we have something in the parentheses. So when it has a minus, do you see what happens really is that even though it says x minus 4, the graph is actually incorrectly moving to the left 4, but it makes the function appear to move to right, but with the coordinate actually moves the opposite direction. So it's kind of like when you put it in the parentheses, you're actually moving the whole coordinate system and the parabola is staying fixed. That's why it goes the opposite direction, is because you're actually moving the coordinate system. So when it says minus, the parabola moves to the right, but the whole coordinate system is actually moving the way you want it to move. So it's kind of opposite what you'd expect. It's the ground moves, not the other. So if you look at some other examples you can take, and I know this doesn't all fit on my tablet at the same time that you're looking at this graph, but if this is a parent parabola where it's 1, but if I change this first slider, you can see how it gets more narrow as I go up and make that a bigger number, and as I get closer to 0, it makes it wider. You can see that's really quick that it makes it 0, and then as it becomes negative, it flips upside down. And then this slider right here, we've already said it moves left to right, it moves opposite, so it kind of moving the whole grid paper, but it made the graph move to the right. And then as I move this last slider, it just simply moves it up or down. But I also did this in another way that can maybe help you see it more visually. I attached my picture to it so you can kind of see what it looks like. If you take any general function and you multiply it by something in the front, that number basically, like we talked about, vertically stretches it. You see how it's vertically stretching the function and vertically stretching my picture, and as you get closer and closer to 0, it vertically compresses it towards the x-axis. And when it hits 0, it should completely flatten out on the x-axis, and it should be upside down at this point, but the program doesn't do what I want it to. It should flip my picture upside down. It should be like the function upside down when it's negative. And so you can see what happens when you have a number in the front. When you have in parentheses x minus something, that's simply it moves it to the left or to the right. But please realize it's opposite, because if it says minus, it really, I know I moved the cursor this way, but it's saying x minus 3.2, which moved it to the right. And the last one moves it up or down. You can see how that moves it up or down. Now, something we did not talk about is there is a such thing as a horizontal stretch or compress, and we'll kind of play with that a little bit more, but you can see as this kind of reversed too, because it's inside the parentheses. If you make that number become inside the parentheses, you multiply by something, it actually causes it to be a horizontal compress of 2, and if you make it closer to 0, like let's say I make 0.5, it actually makes that stretch out by a factor of 2 from the y-axis. So there is a such thing as a horizontal, but we haven't dealt with that just yet, but we will soon enough. Alright, so let's look at these couple examples that we're supposed to do on here. So a regular parent graph is supposed to be right here centered at the origin, but this graph has been moved left 2, so let's do that first. So to make this move left 2, that would suggest, let me make this marker a little bigger, that I would have to put a plus 2 right here, because that's left and right. It has also been moved up 4 to the vertex, has been moved up there, so that would be plus 4 for up 4. And it's upside down, so because it's upside down, I know that the number in front is going to have to be a negative. And if you look at this, basically, usually a normal parabola goes over 1, up 1, but this parabola has gone over 1, and it looks like it's gone down about 3, so it's been stretched a little bit, so I'm going to say negative 3. And with each one of these, you should probably check it in your calculator after you've kind of, and we'll do this some more to practice it, but you should go to y equals and type it in just like you think the equation is to see if it matches. So x plus 2 squared plus 4, and then graph it. I just realized I left off a parenthesis there. That makes a big difference. So I'm going to hit second insert parenthesis. So you can see right here I have that same picture now, and if I graph it, it looks very similar to that graph that I have right here. Alright, let's try it again with this one. Alright, this one has been moved, let's see, to the right, it looks like 2 to get to the vertex. So to move right 2, I'm going to say minus 2. And it looks like it's been moved up 3. So that'll be plus 3 right here. And this one looks wider. I mean, a regular parabola is supposed to start at the vertex and go over 1 and up 1. You can see this one went over 1 at maybe 0.2. So let's suggest that this one is 0.2 because it's wider. If it's fat, it's going to have a number closer to 0. So again, let's graph this and see if it looks something close to that. So if I go y equals and clear that off and type in 0.2 x minus 2 squared plus 3, and see if that graph looks close. And it does. It looks very close. And you don't know the exact numbers. Let me say this again. You really, truly, a lot of times don't know the exact numbers for the stretch or compress factor. It's just an estimate. I just know it was close to 0 because it was stretched out. I knew this was a little more precise because it went down 1/3. But this one, it's hard to tell. It went over 1 and up about, I'm guessing, 0.2. It's just a guess for the blue number. All right, let's try it again with this next one. All right, so the vertex on this next graph has been moved to the right 3. So that would make this a -3. And it has been moved down to, I'm just looking at the very top of the vertex, so to move it down to, I'd say -2. So this is still, when you say minus, it is the same direction. And again, this is a wide parabola. Usually a graph moves up 1 over 1, but in this case it moves over 1 and down about negative, I'm just guessing 0.1. It's just a guess. I know it's negative because it's upside down. I know it's wide, so I know it's going to be some sort of decimal, but what exact decimal is not for sure unless you do a little bit more investigation. But again, all I'm looking for is a close approximation for each one of these. And then the last one, it has been moved to the left 4. So to move it to left 4, I have to put +4 here. And it has been moved down, it looks like 6 to get to the vertex, so I'll have to do -6. And it looks like to me this goes over 1 and up 1, 2, 3. So it's always over 1, and so I'm guessing that's 3. It's upright. So again, it's positive, and it looks like it's a little bit stretched. You can check all these with the calculator to verify they're correct. I hope that was helpful, and please ask your teacher if you need additional help.